Good morning. Today's lesson in industrial engineering, estimating and costing is estimation of foundry cost. Foundry is a shop in which the metal is melted in furnace. The molten metal is poured into the mold cavity. The molten metal is allowed to solidify to get the casting of desired size and shape. Almost every type of article, small or large in size, ranging from few grams to tons of weight, can be cast with proper technique and design. To make good estimate of foundry cost, the estimator must have thorough knowledge upon the material specification, heat treatment specification, inspection, quality control and design of casting, tensile strength, yield strength and chemical composition of material. The estimator must have good idea upon the foundry tools and foundry operations. Generally, the foundry tools are pattern. Pattern is a full size model of casting. It is made by wood or metal. While making the pattern alliances are provided. The pattern alliances are machining alliance, providing excess dimensions over the pattern for removal of material by machining operation to get fine surface finish of the casting. Draft alliance, providing tapered surfaces instead of vertical surfaces for easy withdrawal of pattern from mold cavity. Shrinkage alliance, providing excess dimensions over the pattern to compensate contraction of molten metal on cooling. Molding box, it is the house in which the mold is made. Shovel, it is used for lifting and loading the sand in molding box. Reamers, these are used for packing the sand around the pattern. Trowels, these are used for smoothing, finishing and patching the mold cavity. Lifters, these are used to lift any pebbles or sand particles from mold cavity. In addition to these tools, we are having spruce, gate cutters, bellows are generally used for making the castings. The casting operations generally, the first one is molding. Molding is the cavity formation. This cavity consists the shape of finished casting. Melting, heating the casting material in furnace. By heating, the solid phase of casting material converted into liquid phase of material. This liquid phase of material is generally called molten metal. Shot blasting, it is the foundry operation from which the casting is removed from mould cavity. Fettling, removal of unwanted items like runner, riser and gates from the casting by machining operation is called fettling. Generally, the estimation of foundry cost consists three items. In that, the first item is direct material cost. The direct material consists two portions. In the first portion, it is the cost of material used for production of casting. In the second item, the cost of heating material which are used for heating the casting material in furnace. Generally, the heating materials are limestone, coke, etc. The direct labor cost. The direct labor cost consists the cost of labor charges to the workers who are directly contact with production of castings, and it also includes the cost of labor charges for the workers for firing the furnace, pouring the molten metal in mould cavity, removal of casting from mould cavity, removal of runners, risers and gates from solidified castings. Overhead charges. These charges are generally indirect material costs and indirect labor costs. Indirect materials, the materials which are indirectly utilized for manufacturing of castings is called indirect materials. The cost for this materials is called as a indirect material cost. Generally, the indirect materials are resins, linseed oil, coal powders are generally used as indirect materials for production of castings. Indirect labors, the cost of labor charges to the workers who are indirectly contact with production of castings like supervisors, foremen, inspectors, and also the cost of labor paid for workers like sand mixing, repairing of patterns, storing the finished castings at stock rooms is called indirect labor cost. The cost of foundry tools. The total amount invented over the manufacturing of foundry tools in the form of material and in the form of labor is called total cost of foundry tools. Estimation of moulding cost, it includes the total amount of money spent for making the mould in the form of material and also in the form of labor charges is called estimation of moulding charges. The estimation of melting charges, it includes the cost of melting like preparation of coke bed in furnace, charging the metal in furnace, firing the metal in furnace, removal of slag from the molten metal and allowing the molten metal to flow into the mold cavity. This cost is called as a melting cost of molten metal. Cleaning and grinding costs. It is the cost invented for cleaning the upper surface of casting and also grinding the upper surface of casting to get fine surface finish. While estimating the foundry cost, first of all we have to calculate the direct material cost. The direct material cost can be calculated as follows. Calculate the total volume of casting from drawing. Calculate its weight by multiplying volume with density of material. Add weight of material which was lost due to oxidation reaction in furnace. Add weight of material which was lost by cutting the runners, risers and gates of the casting. Add weight of material which was occurred due to process scrap by remelting the runners, risers and gates of the casting. For this total weight of the material, the cost of material can be calculated by using the formula multiply total weight of direct material with the cost per unit weight. In case of scrap occurs, calculate the total weight of scrap and calculate its cost by multiplying total weight with cost per unit weight of the scrap. By subtracting this total cost of scrap from above direct material, we can get the total cost of direct material in foundry. Now, some of the problems can be done by using the above theory. Now, the first problem is 50 bevel gear blanks are to be casted as per finished drawings shown in this figure. 2 mm machining allowance in the pattern is allowed on each side. Estimate the selling price of one gear blank using the following data. Density of material is 7.2 gram per cc. The pattern is supplied by customer. Cost of cast iron is 30 rupees per kg. Melting charges are 15% of material cost. Administrative overheads are 15% of material cost. The profit is 10% of total cost. Moulding charges are 50 rupees per each mould. The gear blank before machining allowance with dimensions shown in this figure. Now, the problem can be soluted by having clear idea upon the isometric view of given gear blank. The sectional isometric view of bevel gear blank shown here. After providing machining allowance, the elevation of gear blank with all dimensions shown in this figure. This gear blank casting after providing machining allowance is divided into 4 simple parts, namely A, B, C and D. The part A is a cylinder, its isometric view was shown here. The diameter of cylinder is 20.4 centimeters, length of cylinder is 12.2 centimeters, volume A is equal to pi by 4 d square L. By substituting D and L values, the resultant value is 3987.5 cm cubed. The part B is frustum of cone. Its isometric view was shown here. It is called top face of frustum of cone. This surface is called bottom face of the cone. From here to here, it is called height of frustum of cone. The base dia D1 is 35.4 centimeters and top dia is 24.4 centimeters and height h is equal to 3 centimeters. The base and top both are circular in cross section, so their areas are A1 is equal to pi by 4 d1 square, A2 is equal to pi by 4 d2 square. Volume of frustum of cone can be calculated by using the formula h by 3 into A1 plus A2 plus root of A1 A2. Substitute the D1 and D2 values. By calculating, the resultant value will becomes 1878 centimeter cubed. The part C is frustum of cone. Its isometric view shown in this figure. It is the top face, it is the bottom face, it is the height of the cone. The base diameter D1 is 35.4 centimeters, top diameter D2 is 25.4 centimeters, height h is 6.2 centimeters, top and base both are circular in cross section. So, their areas are A1 is equal to pi by 4 d1 square, A2 is equal to pi by 4 d2 square. Volume of frustum of cone C is calculated by using the formula h by 3 into A1 plus A2 plus root of A1 A2. By substituting D1, D2 and h value, the calculated value becomes 4540.7 centimeter cubed. The part D is hollow cylinder. Its isometric view was shown here. From here to here, it is called internal dia of cylinder. From here to here, it is called length of cylinder. Dia of cylinder D is equal to 7.6 centimeters. Length of hollow cylinder is 9.4 centimeters. Volume of hollow cylinder D is pi by 4 d square L. By substituting D and L value, the value becomes 880 centimeter cubed. The part E is counterbore hollow cylinder. Its isometric view was shown here. For this hollow cylinder, dia D is equal to 9.6 centimeters, length L is equal to 2 centimeters. Calculate its volume by using the formula pi by 4 d square L. By substituting D and L, the calculated value becomes 603.4 centimeter cubed. The total volume of casting, part A is a cylinder, part B, part C both are frustum of cones, and part D and E are hollow cylinders. So, they are subtracted here. So, the values of volumes are 3987.5 plus 1878 plus 4540.7 minus 880 minus 603.4. By calculation, the value becomes 8922.8 centimeter cubed. Weight of casting obtained by product of total volume with density of material. Now, weight of material is 8922.8 multiplied with density 7.2, the value becomes 64,244.16 grams. By converting into kilograms, it becomes 64.2 kgs. The cost of gear. The cost of gear consists cost of cast iron, that means direct material. The cost of cast iron is equal to total weight of casting material in kgs multiplied with cost of material per kg. The total weight of casting material is 64.2, the cost of material is 30, by multiplying the value becomes 1926 rupees. Melting charges. From the given problem, melting charges are 15% of material cost. So, 15% means 15 by 100 becomes 0.15, material cost is 1926. By calculation, the value becomes 289 rupees. Molding charges given that 50 rupees. Administrative overheads are 15% of materials cost, that is 0.15 into 1926, the value becomes 289 rupees. Total cost of casting is equal to sum of material cost plus melting cost plus molding charges plus administrative overheads. 1926 plus 289 plus 50 plus 289, the value becomes 2554 rupees. In the given problem, profit is 10% of total cost of casting. So, 10% means 10 by 100, total cost is 2554, by multiplying we can get 255.4 rupees. Selling price is the sum of total cost of casting and profit. The total cost of casting is 2554 and profit is 255.4. By adding these two, the value becomes 2809.4 rupees. Now, in this problem, we have calculated selling price. So, to estimate the selling price, first of all we have to calculate volume of material and then weight of material, and then we have to calculate molding charges, melting charges. If any overheads are there, that values will be added, we get the total production cost of the casting. If any profits are there, by adding the profits we get the selling price of each gear blank from foundry cost. Now, the second problem, estimate the total cost of a CI engine flywheel. CI engine means compressed ignition engine, that means diesel engine. That engine flywheel shown in the figure, we have to find out the selling price of each wheel. For finding the price, we have to assume the following data: cost of pattern is 100 rupees, process scrap is 10% of net weight of material, scrap return value is 15 rupees per kg, cost of cast iron is 35 rupees per kg, administrative overheads are 50 rupees per piece, the selling overheads are 25% of production cost, the profit is 15% of total cost, moulding charges are 120 rupees per hour, moulding time 50 minutes, moulding overheads 30 rupees per hour, pouring time is 15 minutes, pouring charges are 60 rupees per hour, pouring overheads are 20 rupees per hour, the shot blasting is 60 rupees per hour. The shot blasting time is 10 minutes, the shot blasting overheads are 30 rupees per hour, fettling is 60 rupees per hour, the fettling time is 30 minutes, the fettling overheads are 20 rupees per hour. The engine flywheel elevation and side views are shown in this figure with dimensions, but here it is called rim of the flywheel, it is called hub of the flywheel, it is called arms of the flywheel. The arms of the flywheel consists elliptical in cross section. Now, this problem will be soluted as follows. The given flywheel consists three parts. The part A already we have explained, it is a rim, the rim is a hollow cylinder, its isometric view was shown in this figure. Outer dia of this rim is 80 centimeters, inner dia D2 is equal to 66 centimeters, width is taken as L is equal to 15 centimeters, volume of rim denoted by V suffix A is equal to pi by 4 d1 square minus d2 square into L. By substituting d1, d2 and L value, by calculating, the value becomes 24,080.3 centimeter cubed. The part B is a hub. The isometric sectional view of hub was shown here. It is a hollow. It is the thickness of the hub. It is outer dia, it is inner dia. Now, hub is hollow cylinder, its outer dia D1 is 15 centimeters, inner dia D2 is 10 centimeters, width is taken as L is equal to 25 centimeters, volume of B calculated by using the formula VB is equal to pi by 4 d1 squared minus d2 square into L. Substituting d1, d2 and L values, the calculated value becomes 2454.4 centimeter cubed. The part C is a arm. The isometric view of arm shown in this figure, its cross section consists elliptical. From here to here, it is called length of minor axis. From here to here, it is called length of major axis. From here to here, it is called as a length of arm. In the given problem, volume of each arm is calculated by using the formula pi into A into B into L, where A is length of semi major axis, given that 7 2A, length of major axis is 2A, that is 7, So, small a is equal to 7 by 2. Similarly, length of minor axis 2b is equal to 4, length of semi minor axis b is equal to 4 by 2, length of each arm from figure 80 minus 15 minus 7 by 2, the value is 25.5 cm. Volume of C is pi a b into L. Substitute a is equal to 7 by 2, that means 3.5, b is equal to 4 by 2, that means 2, and the length is 25.5. The value becomes 560.7 centimeter cubed. Total volume of material is volume of rim V A, volume of hub V B, volume of 4 arms 4 V C. Substituting their values by calculation, the value becomes 28,777.5 centimeter cubed. Given that density of material is 7.2 gram per cm cubed, weight of each casting is the product of total volume of casting into density. Substitute the total volume 28,777.5 into 7.2. So, the value becomes 2,07,198 grams. By converting into kilograms, it becomes 207.2 kgs. The weight of scrap is 10% of weight of each casting, that means 10 by 100 into weight of casting 207.2. The value becomes 20.72 kgs. Gross weight of the casting is equal to weight of casting plus weight of scrap, that means 207.2 plus 20.72, the value becomes 227.92 kgs. The material cost is the product of gross weight of casting in kgs with cost of cast iron in rupees per kg. So, the value is 227.92 multiplied with 35, you can get the value 7,977 rupees. Amount recovered from scrap, weight of scrap into rate of scrap. So, the value becomes 311 rupees. Actual material cost is material cost minus amount recovered from scrap. 7,977 minus 311, the value becomes 7,666 rupees. The pattern cost he has given as 100 rupees. Labor cost is calculated separately for moulding charges. Moulding charges per hour into moulding time per hour, that is 120 into 50 minutes. Minutes are converted into hours, 50 by 60, we can get the value as 100 rupees. Pouring charges per hour into pouring time per hour, that is 60 into 15 by 60, the value becomes 15. Shot blasting charges, the product of shot blasting charges per hour with shot blasting time per hour, that is 60 into 10 by 60, the value becomes 10 rupees. Fettling charges, it is the product of fettling charges per hour with fettling time per hour, that is 60 into 30 by 60, that value becomes 30 rupees. Labor cost, so the labor cost is the sum of moulding charges, pouring charges, shot blasting charges and fettling charges. So, by adding 100 and 15 and 10 and 30, the value becomes 155 rupees. foundry shop overheads. The foundry shop overheads consists moulding overheads, pouring overheads, fettling overheads. Now, the moulding overheads is equal to product of moulding overhead charges per hour with moulding time per hour. The values are 30 into 50 by 60. So, the value becomes 25 rupees. Pouring overheads is the product of pouring overhead charges per hour with pouring time per hour. The values are 20 and 15 by 60, it becomes 5 rupees. Shot blasting overheads are the product of shot blasting overhead charges per hour with shot blasting time per hour. The values are 30 into 10 by 60, it becomes 5 rupees. Fettling overhead charges are product of fettling overhead charges per hour with fettling time per hour. These values are 20 and 30 by 60. By calculation, the value becomes 10 rupees. Therefore, foundry shop overhead charges are the sum of mouldy shop overheads plus pouring shop overheads plus shop blasting overheads plus fettling overhead charges. By substituting their values and by addition, the value becomes 45 rupees. Administrative overheads are 50 rupees. Production cost is the sum of material cost, labor cost, pattern cost, foundry overhead charges and administrative overhead charges. By adding all these items, we get the production cost of the casting. Now, material cost is 7,666, labor cost is 155 and pattern cost is 100, foundry overhead charges are 45, administrative overhead charges are 50. By adding all these items, the value becomes 8,016 rupees. In the given problem, sales overheads are 25% of production cost. 25% means 25 by 100 into 8,016. By calculation, the value becomes 2,004 rupees. Total cost is the sum of production cost and sales overheads. So, production cost is 8,016, sales overhead is 2,004. By adding these two items, the value becomes 10,020 rupees. Given that profit is 15% of total cost, that is 15 by 100 into 10,020. By calculation, the value becomes 1,503 rupees. Selling price of each wheel is the sum of total cost of casting plus profit. Total cost of casting is 10,020 and profit is 1,503 rupees. By adding these two items, the value becomes 11,523. Now, in this problem, the scrap value was given and the pattern was utilized by producer and also the moulding charges direct and indirect, melting charges direct and indirect, shot blasting charges direct and indirect, fettling charges direct and indirect and also administrative overhead charges are given. So, we have calculated separately the moulding charges, melting charges, fettling charges, shot blasting charges and all are added to total material cost, we can get the total production cost. After that, we have calculated the profit and also selling price of each and wheel. By this, we have completed the theory part as well as problematic part of estimation on foundry cost. Thank you. In next class, I come with a new chapter. Until then, thanks for all.